question is, which one's the x-axis and which one's the y-axis? Freddie.
The x is the side to side, the y is the...
Good. So the x-axis is the horizontal line, or the side to side. And the y-axis is the vertical line. Okay? Now, which part of this graph is quadrant 1, quadrant 2, quadrant 3, and all that good stuff? Yes, Dakota?
It goes like the top left is 1, the top right is 2, the bottom left is 3, and then the bottom right is 4.
The top right is the first quadrant. It's Q1. You're almost right. The top left is your quadrant 2. The bottom left is your quadrant 3. And the bottom right is your quadrant 4. I just wrote down Q. Okay. Right. It's quadrant 1, 2, 3, and 4. What is the origin? You know what that is? Whatever complicated. Yeah. Freddie. Yeah. The middle. And what point is that according to like an x and y? 0, 0. So my origin is at 0, 0. Okay. We are moving right along. Now, two key words that you will see throughout your mathematical journey, call it, is domain and range. Domain and range. Essentially, what is the domain? What does that mean? That's the x. Anytime you see the word domain, it's talking about those x values. Okay? So, what's the range then? Y values. Okay? Now, just a brief overview. I think everybody knows how to graph a point, but just in case. Let's say if we had a point of 2, 4. Okay? If I wanted to graph this out, the point 2, 4, I would go over to the right 2, and then I would go up 4, and I'd make my point. Okay? And if it's negative, if the x is negative, you're going to be going left. If the y is negative, you go down. Okay? So my first one is my x, my second one is my y. Basic graphing. A function. Okay? First off, if we're looking at a graph of a line, let's say if we have a line like this. Okay? There's something called the vertical line test. Something called the vertical line test to determine if it is a function. And this is how you figure it out. If you draw a vertical line, so my green is my imaginary vertical line, and it only hits the graph, the line, one time. So do you see my point right there? It only goes over the graph one time. If it only hits the line one time, then it is a function. So that'd be a yes.
I thought you did it like all the way across the graph.
And yes, now notice my line is all the way to the right. Okay? that vertical line test has to be all over that line. No matter where you do it, no matter where you draw that dotted line, it can only hit that red line one time. Has to be the whole thing. If it only hits it one time, then it's a function. Let's say if we have a graph like this. And I want to determine if that's a function. Now this is what Dakota was talking about. Let's say if I drew my dotted line right here. Well, that's true. It only hits the graph one time, or it only hits that line one time. But you have to understand that you have to be able to draw that vertical line no matter where on that graph it only hit it one time. Now that second one right there only hits it one time. That third line only hits it one time. But this last line hits it there and hits it there. So this would be considered not a function. So that is not a function. Now a typical graph that you'll see is maybe something like this. You'll see it like that. Is that considered a function?
No.
Why? Because if I do my vertical line, it's going to hit it twice. So that's a no also. Let's say if we have one that looks like this. Would this be considered a function?
Yeah.
Absolutely. If I did my vertical, now, I'm sorry, my graph is, my red line is a little bit straighter than I'd like it. Sorry about that. Yes, this would be considered a function. Okay? Because if I did a vertical line, now I know my graph is not up to par, but that's considered a parabola. And it's that U shape. Now, even though it looks like it's almost a straight line, which that almost is a little bit straight line, sorry about drawing that. Now, the next way to determine if it is a function or not is to look at the coordinates. Now, the only thing you need to look at, the only thing, is the x values. Okay? That's it. If there are not multiple x values, then it is considered a function. So let's look at this. Looks like I have a 3, a 2, and a 5. Do I have any multiple 3s or multiple 2s or multiple 5s? No, I do not. So this would be considered a function. So this is a yes.
So as long as there's no more than one number of each one.
Of the x. Now notice, look at my y values. Oh, hello. Look at my y values. I do have multiple 4s, but when determining if it's a function or not, you don't even need to look at those. Okay? As long as those x values are not the same, it's a function. So according to our rule, is that second table a function? Why?
Because it repeats the same.
Yeah, we got multiple negative 2's right there, so that's not a function. That's not. Let's look at one more example. Another way you might see it is something called mapping. Bless you. something called mapping, and it looks something like this. They'll have X and Y values just like they have for a table, but they'll have these arrows pointing. Okay? All that means is, you guys understand what that means? So that table right there, that's called mapping. So that's a yes also. Now one that is, let me show you one that does not. Now, for this one up top, I know it's my drawing is a little bit sketchy. For this one up top, notice that my 6 has 2 arrows pointing away from it. Okay, so my x coordinate is 6, 5, and it is also 6, 0. So would this be considered a function? No, because there's multiple 6's. But I do not know my y value. Function notation is something that you can use to figure that out. Now there's one thing, or there's a couple things about it that you need to know. First off, you need to know what the equation is. Now what I mean by that is, what is the equation of the line? And I think one of the textbooks has a good illustration of it. To me, it's something like this. Think of it as you're putting something in and you're getting something out. Think of it as an input and output. So we can insert 3 into an equation and it's going to spit out our y value. So let's say our equation is something like this. I don't know. Let's say our equation looks like this. Now there's something that you will see a lot when you're dealing with function notation is this f of x. And that's how it's pronounced. F of x. Okay? So if you need to do this to the side over here, this really means f of x. Okay? F of x, that's how it's pronounced. Let's say if it was g, and there's an x right there. What do you think that, how do you pronounce that? G of x. Now, typically you'll see it as f, but you will see it as g also. Let's say if it was h and there was an x beside of it. How would it be pronounced? H of x. Man, you guys are smart, I'll tell you that much. You guys are on a roll. Now, this is how you solve this. So we're going to have an input of 3. Okay? So we're going to input 3, and we're going to input it into our equation n for x. Anytime you see an x, and let's say we're looking for what the coordinate is for 3 what, whatever the x value is, just put it as your input and plug it in right here. Just plug it in for x. That's all you're doing. From there, you're just solving. So 2 times 3 is going to give me what? Plus 1 is going to give me what? 7. So my output is 7. So that tells me that my y coordinate is 7. Let's say if we're using the same equation. And let's say I want to know what the coordinate is for 6. What's my y coordinate for 6? I can use that equation to figure it out. All I'm going to do is, I'm just going to write below right here. Now, one thing you'll see it as is this. If we're looking for 6, you'll see an f of 6. Now, that means you're just going to leave that be. That just tells you what you're looking for. You're looking for the y coordinate that's associated with 6. Insert 6 in for x into our equation. So 2 times 6 is going to give me what? Plus 1 is going to give me what? And we are done. Okay? So what's my y coordinate? Well, we just figured it out. It's 13. That does. That tells me what number I plug in for x. Now from here, all I'm doing is solving. 3 times 4 gives me what? 12. Plus 2 gives me what? I'm done. That's your answer. 14.
But where did you get the 4 from?
That f of 4 right there, I probably should make that a little bit bigger. Do you see that, Dakota? That's a 4 right there. Okay, let's say if I'm looking for f of 4. That tells me what number I plug in.
So when you're doing an equation,
Same procedure. Whatever number I'm looking for, that's what I'm going to plug in for x. If I'm looking for negative 2 right here, all I'm going to do is plug in negative 2. Now notice I put parentheses about when I inserted that. Now it can be confusing because that's a negative number, so that's why I did that. That's probably the easiest way to do it. Just put whatever you insert into parentheses.
answer 6.
Good. So now I would just solve it from here. Negative 2 squared is going to give me a positive 4. Two negatives become a positive, and we're actually going to add 4 plus 2, which gives me 6.
Is that negative 4 plus 2?
That's a positive 4 minus a negative 2.